Assalamu alaikum, dear students. Welcome to your channel, Mathematics Online. As you know, in the previous lecture, we have started relations and functions. And in that lecture, we have discussed some types of relations and we illustrated them with some examples. Now, here in this lecture, we will be discussing exercise number 1.1. That's based on, once again, the types of relations, that is reflexive relation, symmetric relation, and transitive relation. So in the first question, we are being asked here, we have to check whether this relation given in part number first of question number first is reflexive, symmetric, or transitive. The relation is given by r is equal to xy, y 3x minus y is equal to 0. We have to check whether this relation is reflexive, symmetric, and transitive. You know the definitions of these types of relations. So first of all, we will do one thing. We will check whether it's reflexive or not. For reflexive relations, we should have xx belongs to the given relation. You see, here we have 3x minus y is equal to 0. Okay, so we have to write those ordered pairs that satisfy this equality. So the ordered pairs which satisfy this equality are 1, 3, 2, 6, 3, 9, 4, 12. Because you see, if you will solve this equation, you will get y is equal to 3x. So you have to write y as 3 times x. So it's 1, 3, 2, 6, 3, 9, 4, and 12. So now this relation can be examined for the reflexivity. You see, this relation is not reflexive because there is no 1, 1, there's no 2, 2, there's no 3, 3, dash and dash. So this is not reflexive. Is the symmetric? We will check. 1, 3 belongs to this relation, but 3, 1 does not belong to this relation, so on and so forth. So it's not symmetric. Now, is this transitive? You see, 1, 3 belongs to this, 3, 9 belongs to this, but 1, 9 does not belong to this. So it's not transitive. So this relation is neither reflexive, nor symmetric, and not transitive. Okay? Hence, it is not an equivalence relation. On the same lines, we can solve other questions. Okay, a question, say part number second of this question, part number third of this question. Let's go to part number fourth of this question. We will highlight it here. You see, in part number fourth, we are being asked here, we have to check whether r is equal to xy ordered pair, where x minus y is an integer. Is this reflexive relation symmetric and transitive? You see, difference of any two integers is an integer, and difference of two integers, same integer, when we subtract that from itself, that gives 0, and 0 is an integer. So we say xx belongs to this relation, hence it is reflexive. Next is for xy belonging to the integers, xy, this ordered pair belongs to R, then x minus y is an integer. Okay, if x minus y is an integer, minus times x minus y is also an integer, because for example you have 1, 2, 3, these are integers, their negatives are also integers. So minus times this is also an integer. We will multiply this inside the braces, we will get y minus x. This is also an integer. So yx is also an integer, and hence y comma x belongs to this given relation. Therefore, it is symmetric. Now we will check the transitivity of this relation. For that, we have to take 3 ordered pairs. We have to first of all take 2 ordered pairs, and we should check whether third ordered pair that gets transited from these 2 ordered pairs belongs to the given relation or not. If that belongs to given relation, then it is a symmetric, transitive relation. If not, then it is not a transitive relation. Let's suppose xy belongs to this. That means x minus y is an integer. Let's suppose yz belongs to the given relation, then y minus z is y minus z is an integer. Okay. Now we will go to x minus z. X minus z can be written as x minus y plus y minus z. We are actually adding and subtracting y here. So x minus y plus y minus z is an integer. Okay. If this is also an integer, that means x minus z is an integer. If this is also an integer, we say that it is transitive. Hence, given relation is reflexive, symmetric, and transitive. So we say the given relation is all the three types of relations. This criteria is satisfied. We say this is an equivalence relation. Okay. I hope that you got it. In the next questions of say it's part number 5th, relation R. In the set A of human beings in a town at a particular time given by R is equal to XY, work at the same place. You see, X and Y, they belong to the relation if they work at the same place. It is so natural that we can say X and X, it belongs to this relation, therefore it is reflexive. If xy belongs to R, that means x and y work at the same place. We can say other way, y and x belongs to R because y and x work at the same place. Therefore, it is symmetric. For transitivity, if xy belongs to R and yz belongs to R, this means xy belongs to R means x and y work at the same place. This means y and z work at the same place. We can make a transition from these two ordered pairs. We can say that first and third person work at the same place. That's x and z belongs to R. Therefore, R is transitive. Hence, it is reflexive, symmetric, and transitive. On the same lines, we can solve these questions. Say, part number E is here. R is equal to xy, x is father of y. X is father of y. We will take those ordered pairs where the relation father is where the two are related by the father-son relation. So xy belongs to this R. If x is father of y. You see this, I have solved all these questions. We will go to part number E. xy, so x is father of y. X and x cannot belong to R because this is an absurd statement. Okay, as x cannot be father of himself. So this is not reflexive. Is the symmetric? No. Why? Because let xy belongs to R, that means x is father of y. If we will take this as x is father of y, we cannot say y is father of x in any case. So this is not a symmetric relation. Is this transitive? No, it's not. Because let xy belongs to R, that means x is father of y. Let yz belongs to R, that means y is father of z. X is father of y is father of z. That means x and z, they have a relation of grandfather. Okay, so x is grandfather of z. If x is grandfather of z, it's not a father-son relationship, so it's not transitive. I hope that you got it. The rest all the questions will be solved in the next lecture. Thank you for joining the class. Thank you.